Okay, so now that we've worked with functions for a little bit, the next thing that we're going to do is try to build functions from other functions. And so here we're given two functions. The first one, f of x equals x squared minus 4. And the second function we have is g of x is equal to the square root of x plus 1. And we're asked to find all of these function expressions, f of x times g of x, and I've just excluded the parentheses x here in order to keep this a little bit shorter. F of x divided by g of x, and then g of x divided by f of x. Okay. And so, and also ask us that to give the domain of each of these expressions after we figured out what they are. So it's probably best to start just by finding the domain of f of x and the domain of g of x. And so let's just find the domain for f of x. Okay. Now you see here the two rules that we have for finding domain, that we can't divide by 0, and since there's no division here, we don't have that problem. And the second rule is we can't take the square root of a negative number, and since there's no square roots here, everything's going to be fine because I'm not taking the square root of anything. So for f of x, the domain is all real numbers, okay? Or we can write it this way in interval notation, from negative infinity to positive infinity. Okay? Let's look at g of x. Since g of x has a square root, x plus 1, okay, we know that whatever is inside the square root has to be positive or equal to 0. So I know that x plus 1 has to be greater than or equal to 0. So x has to be greater than or equal to negative 1. Or in interval notation, that's going from negative 1 inclusive, this should be a bracket, to positive infinity. And so once keeping these two things in mind, once I'm able to find the domain of f of x and g of x, I'm going to have to refer back to this when I find the domain of these expressions up here. Okay? And so let's just walk through these function operations. So now I have part A here, f of x times g of x, and what that means is I just literally write it out. F of x is x squared minus 4, and I have to write out the entire function, and then g of x is the square root of x plus 1. And there you have it. This is all there is to it. This is f of x times g of x. Now, if there was some way, if there were some constants in here, I could multiply them out and try to simplify it further. But in this case, this is as far as I can go. And let's check on our domain. So I still have this this expression, square root of x plus 1. And so I have to make sure that this expression here cannot be less than 0, or it cannot be negative. So I still have to check that x plus 1 is greater than or equal to 0. So then x has to be greater than or equal to negative 1. So it's the same thing as what I have before. And if you notice something here, the domain of f times g of x, it's the more restrictive one, right? It's f of x can be anything. You can put anything into f of x. G of x is very restrictive, and when you combine those two together and multiply them, it's the more restrictive one, the one that has more limitations on it. Now let's find answer part B here. What is f over g? So f over g, same thing here. I just write out x squared minus 4 divided by square root of x plus 1. And you can probably guess at this time that we're going to have to repeat the same process again to find the domain of this function. Okay? And this expression here, I have, again, x plus 1 is greater than or equal to 0, so x has to be greater than or equal to negative 1. Okay? And so that sort of is inherited from g of x. Okay, so the domain of g of x seems to follow us through all of these function expressions. Okay, but now you see that the square root of x plus 1 is in the denominator, so now we have a new restriction, that namely the denominator cannot be equal to 0. So I have to check and make sure that the square root of x plus 1 is not equal to 0. I want to square both sides, and that gives me x plus 1 is not equal to 0. And it means x cannot be equal to negative 1. Okay, so these two restrictions are my domain. It says here that x has to be greater than or negative 1, and x can't be negative 1. So when I combine these two together, this not equal to essentially takes away the little bar here. So in my final answer, my domain is going to be x is greater than negative 1. Okay? Or in interval notation, negative 1 to positive infinity. Okay? And you see all this has changed, all this has really changed here is made it so that this square bracket up here, it means that it can be equal to negative 1. Now it's a parentheses or round bracket. That means it has to be greater than negative 1. And so let's just finish out our last problem here. This last part asks us to find g over f. Okay, and so I write out the expression for g, and that's square root of x plus 1. The expression for f is x squared minus 4. Okay, and at this point I guess we don't have to do this a fifth time. Okay? We know that x has to be greater than or equal to negative 1 because this is inheriting it from g of x. Now we just have to make sure that there's nothing new that gets introduced into this concept. Okay, and you can see here that I have a denominator, so I know that x squared minus 4 cannot be equal to 0. Okay, so that means x squared cannot be equal to positive 4, and x cannot be equal to negative 2. X cannot be equal to positive 2. Okay, so it has to be greater than or equal to negative 1, but it cannot be equal to positive 2. And let me just draw this out here on the number line. So I have negative 1 here, negative 2 here, and positive 2 over here. So I already know that it's got to be greater than or equal to negative 1, but it can't be equal to 2. Now if you notice here, this negative 2 is also in here, but it's completely irrelevant.